This example comes out of section 9.3, connecting graphs and rational equations. In this question we look at another rational equation and we'll try to figure out what x equals. Now, before I figure out what it equals, I suppose I should talk about what it doesn't equal. If I factor this as a difference of squares, this particular term here, I can see that there are two things that x cannot equal, two non-permissible values, and they are that x can't equal plus or minus 4. Those would both make me, either one of those would make me divide by 0, which means it would be impossible to find the solution. Now, a graphing solution, you may, graph the left side, graph the right side, see where they intersect, or since we did that in the last example, let's try graphing y equals, and just put the whole thing to one side. So 8 over x squared minus 16, put that in brackets on your calculator, plus 1 minus 1 over x minus 4. Again, brackets on your calculator. Strange looking graph a little bit. It does have non-permissible values at -4 and +4. At -4, it's got a vertical asymptote. At +4, it actually turns out that it has something else going on. But if we take a look at this graph, it looks something very roughly like this. And so what I'd be looking for, since I moved everything to one side, is I'm wondering when would this equal 0. And so I would do second trace 0, have to do the left bound, right bound business, and find myself an answer. And that answer, my graph picture here isn't particularly good because the answer looks like it's at x equals -3. Now if I solve this thing algebraically, I have 8 over x squared minus 16 plus 1 equals 1 over x minus 4. The first thing I would suggest you do is factor as we did up above, so x minus 4x plus 4 plus 1 equals 1 over x minus 4. Multiply everything by the common denominator, meaning multiply every single term by x minus 4 times x plus 4 on the left side and on the right side. Pardon me. The reason why we would do that is that will get rid of all the denominators in the question. And so in doing that, you're going to be left with 8 plus x minus 4 times x plus 4 equals x plus 4. A much simpler looking thing to solve, just in the fact that it doesn't have denominators. So expand this thing out, I get x squared minus 16 and x plus 4 on the right side. So bring it all to one side, you have x squared minus x minus 8 minus 4 is minus 12 equals 0. If I factor it, I get x minus 4 times x plus 3. Two numbers that multiply to give me -12 and add together to give me minus 1. So two answers I get are x equals 4 and x equals -3. This is one of these cases that, and that's why I chose this example. I stole it right out of your book, but mainly I chose it because it gives us two answers, only one of which is a good answer. Why is x equals 4 not a good answer? If you go all the way back to the beginning of this problem, we know that one of the non-permissible values, our non-permissible values, is that x can equal plus or minus 4. So this is what we call an extraneous answer. We didn't make a mistake in finding it, but it doesn't actually satisfy the original equation. And so our only solution to this is that x equals -3, the same answer we got in solving it graphically.